So firstly, I will show the open loop circuit of 3-level boost converter. In this circuit, I'm using voltage input of 7.4 volt and output voltage of 12 volt. From that, I get duty cycle of 0.458 from the voltage conversion ratio. So this is the output voltage waveform of an open loop 3-level boost converter, which is supposed to be 12 volt. The open loop output voltage waveform, there is a lot of oscillation before it reached its steady state at 12 volt. In 3-level boost converter, it consists of two regimes, which is voltage input, voltage input is less than half of the output voltage, and with voltage input higher than the half of the output voltage. So now I'm using voltage input higher than the output voltage, half of the output voltage. My voltage input is 12 volt and half is 7.4 volt, and half of the output voltage is 6 volt. So because of I'm using second regime operation, the duty cycle is less than 50%. So I'm using the signal waveform like in the figure B. To get the PWM signal, I will compare the voltage and the triangle signal, and then we get the PWM signal. So in this 3-level boost converter, it consists of two switches. So one switches will be the above one, and then the other switches will be the bottom one. In the first triangle waveform, I put 050, so the sequence, and the other triangle waveform should be 505. So and I will get this same like the same like in the figure B. So this is the block diagram of a closed loop block diagram of a 3-level boost converter. 5 volt as a V reference, gain 5 over 12 because of my voltage output is equal to 12 volt, and my 1 over Vm is equal to 1 over 5. This is the transfer function of a type 3 compensator, and this is the transfer function of a 3-level boost converter. I will tune the transfer function of type 3 compensator so that I get the desired phase margin, gain margin, and also the bandwidth. To do that, I'll go to the control system designer to tune the block diagram, to tune the type 3 compensator transfer function. Alright, then from there I using PID tuner. From here I'm using PID tuner and update the compensator, and the 0 and the pole location will be adjust. So from here I will it shows the gain margin and phase margin, and also the cutoff frequency. Problem here is that I still not cannot get the desired phase margin, gain margin, and also the bandwidth that I want. I tune the type 3 compensator. I will move this block to the closed loop circuit. So this is the closed loop circuit of 3-level boost converter that I adding type 3 compensator to the circuit with a V reference of 5 volt, gain 5 over 12, and 1 over Vm, So this is load disturbance that I already added every 0.02 second. So on every 0.02 second there will be a uh, feedback action from the type 3 compensator, and it reaches steady state back on every 0.006 second. As we can see, on every 0.02 seconds there is load disturbance, and there will be a feedback and reach its steady state at 0.06 second to at a 12 volt. That's all from me. Thank you.